Alright, Mr. Allred here. We've been talking about mean, median, mode, range, standard deviation. So we're going to do some practice problems here. The first one, the weekly salaries of 6 employees at McDonald's are, in dollar form, 140, 220, 90, 180, 140, and 200. For the 6 salaries, find the mean. Okay? So the first thing we're going to do is find the mean. And we already know there's 6 of them. We might want to double count. 1, 2, 3, 4, 5, 6. So we're going to add them up and divide by how many there are. So we're going to add those 6 numbers together. Which gave me a total of 970. And when I divide by 6, I get 161.67. If I talk about money, I usually take it to the nearest penny. The next one, the median. So I need to put them in order. So 90 is the smallest. That looks like 140, 140, 180, 200, and 220. So I need the middle one, but there's 6 of them, so I have the middle 2, which is 140 and 180. So as I said, if there's an even number of items, you will take the middle 2 and add them together, which I believe that's 320 when I add 180 and 140. Alright, and I'll divide that by 2, and I believe that is 160. So that will be the median. It's not even in our list, but a definition of the median and the way we find it, that is the median salary here. And then the mode, there's more than one benefit to putting them in order, because now we can see that 140 showed up twice, okay, more than anything else, and that's unimodal since there's only one mode there. Okay, let's move to the next question. It says Andy has grades of 84, 65, and 76 on 3 math tests. What grade must he obtain on the next test to have an average of exactly 80 for the 4 tests? So let's see here. Let's talk about how he would calculate an average. He would say 84 plus 65 plus 76, and he's got another test, which we'll just call X, all over 4. And that has to equal 80. Well, we're only going to do a little bit of algebra here. We're going to multiply both sides by that 4, so we will have 320 on the right-hand side. And let's see. 84 plus 65 plus 76 will be 225 plus x. So when we get x by itself, 320 minus 225, he must make a 95 on his last test, which kind of makes sense because he has 2 grades lower than an 80, one of them much lower than an 80, the 65, and 1 grade above. So it kind of makes sense that he needs a high grade to pull his grade up. Okay. The next one, 3. A store owner kept a tally of the sizes of suits purchased in her store. Which measure of central tendency should the store owner use to describe the average size suit sold? I guess we could argue about this, but my thought would be to use the mode, because she is more does it say? Yeah, it does say she, her. She is probably more interested in what she sells the most of. So it wouldn't make much sense if she sold one of every suit to average them together. Okay, so I think she would be more interested in the one that she sells the most of if she was going to try and describe that to somebody. B. A tally was made of the number of times each color of crayon was used by a kindergarten class. Which measure of central tendency should the teacher use to determine which color is the favorite color in the class? So number of times each color crayon was used. So since color does not work very well mathematically and it would be kind of hard to order those, I would once again say the mode. She wants the most popular. C. The science test grades are posted. The class did very well. All students taking the test scored over 75. Unfortunately, 4 students were absent for the test and the computer listed their scores as 0 until the test is taken. Assuming that no score repeated more times than the 0, what measure of central tendency would most likely give the best representation of this data? Well, the average is a bad score, a bad representation since there's 4 zeros tallied in there. I would also say that the mode would not be good because it sounds like more students made a 0 than anything. So I would say put them all in order and use the median, the one in the center of the data. It might be a little bit lower than the average without the zeros, but for now I think it's better than the other 2 options. Okay, let's see what type of questions we got down here. Number 4. The value of houses on Washington Street are shown in the table below. Value per house and number of houses. So we've got a value and then we have a frequency table more or less. It says find the mean value of these houses in dollars. So more or less we're going to have to not only add things up, but we're going to have to kind of multiply across here. So when we go to find the mean, we're not going to have 4 houses because we have 4 different pieces of data here. We've actually got 1 plus 5 plus 4 plus 1, which is 11 houses. So we're going to say 100,000 times 1, which would be 100,000, plus 175,000 times 5, which looks like 875,000. 200,000 times 4, which is 800,000. And then one $700,000 house. Got my comma a little early there. No blue. $700,000 house. We're going to add all those up. And divide by 11. So let's see here. 100,000 plus 875,000 plus 800,000 plus 700,000 divided by 11. It looks like the average is 225,000. So let's put that up here. 225,000. And then it says the median. What is the median value? So we just said there were 11 houses. So there is a middle, and it would be, if you wrote all these out individually, it would be the 6th house, 5 from each end, which is 175,000. And it says, state which measure of central tendency, the mean or the median, best represents the values of these houses. Justify your answer. Well, looking at the 4 different values over here, the 700,000 is way different than all the rest. Okay, the next highest is 200,000. I would say in this case that it would be the median, because when you say that the average is 225,000, there's only one house above that average, so it doesn't give a really good representation. If you told me I was moving to a neighborhood where the average house value was 225,000, but I was buying a $100,000 house, it would seem kind of weird. So that one $700,000 house is really messing up the data there. Let's see what else we got down here. Alright, the ages of the local hockey players are 17, 15, 16, 19, 17, 19, 22, 17, 18, 21, 17. What is the mean of their ages? So let's see. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Since we got a couple things to do here, I'm going to go ahead and write them down in order. So let's see here. 15, 16, then looks like 17, 17, 17, 17. 4 17s. Then an 18, 19, a 19, 18, 19, 19, 21, 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them. So what does the mean? Well, it's whatever this total is divided by 11. So let's add them up. I got a total of 198. And I'm going to divide that by 11. I got an average of 18. What is the median age? We said there is an odd number, 11 of them. 1, 2, 3, 4, 5, 6. 17 is the middle. So that is the median. And the mode is also 17. That's obviously the most. And what is the range? 22 minus 15 is 7. So there's at most 7 years between any two hockey players here. Okay. Let's see here. Number 6. The front row of a movie theater has 23 seats. If you were asked to sit in the seat that occupied the median position, in which seat would you sit? Well, we could write out 1 through 23 and pick the middle, but it would be seat 12 because there would be 11 seats over here, and there will be 11 seats over here. So basically you can divide the total by 2 and round up if you get a decimal. Okay. Let's see here. Number 7. Jackie has 2 brothers. There are 2 sets of twins. Their ages are 21, 15, 15, 7, 7, and 2. Calculate the median and mode of their ages. Is there anything special about the mode? Well, to do the median, we need to put them in order, and I guess they already are in reverse order. So the median is the 15 plus 7 divided by 2. So I guess that's 11. So right here are the middle 2 terms. The mode is 7 and 15. And it says, is there anything special about the mode? I would just say there's 2 of them, unexpectedly. And that's where I would kind of leave it. All right. We'll stop here and pick back up later. Thank you.